For culinary math, again, I realize most of you have already learned the concept, the overall concept of the math that's required when you're dealing with anything in the culinary baking field. You've heard it from Chef Webb, from Chef Chad, other chefs. I don't know that you've heard it from me. So I ask that you keep an open mind, even though you have learned these materials before, a refresher, or look at this as an opportunity to hear it in a different viewpoint. And hopefully things will click if they haven't before. So first thing I want to cover and talk about, and hopefully you can see this, volume versus weight. And that's an extremely important concept. If you don't know the difference between the two, then as we're working through a lot of these calculations, you'll get lost in the mix. So it's important to realize volume takes up space. Okay, so an example of a volume measuring cup would be, well, this is your volume measuring cup, but this is a liquid measuring cup. Only liquids go in here. If I needed to measure a cup of walnuts, I would not want to put a cup of walnuts in here. This is only for liquids, okay? Now, this is measuring the space it takes up. It's not measuring how heavy it is, the force of gravity pulling down on it. It is measuring the space it takes up in this container. Another one, same thing, a measuring cup. It's going to take the space of the container. How about this? Drop stuff all over the floor. How about this? This is a scoop. And now this is a 4-ounce scoop. I like to think of it as an ice cream scoop. If you have not seen these before, this is a measuring tool to keep consistent measure when you're portioning out. Think very old school in diners, even mashed potatoes, mac and cheese on a banquet. It's to get the same size portion every single time. Can you see how I'm filling up space when I'm doing that? That is a volume measurement, right? I'm filling up space. There is no measurement involved as far as weighing this. And this is a 4-ounce scoop. How you tell, right on the inside, which I realize you're not gonna be able to see, but on the inside here, woo, I'm backwards. Okay, can you see that little thing going around here? That's what scrapes out the bowl. There's a number on that. This number here is, just to verify, number 12. So I said this was a 4-ounce scoop. It's actually really not, because what you would do is say, how many of these scoops can I get out of a 32-ounce container of ice cream, 1 quart? So if I have a number 12 scoop, I'm actually a little bit closer to the 3-ounce mark. I would take 32 ounces divided by whatever number is on here, and that would give me the ounce size scoop. But that's not what I'm getting at first. What I'm getting at is this is volume. I'm taking up space, right? I'm taking up the mashed potatoes to fill this and then portioning it out, right? Another one, and these come in all different sizes also, right? It starts, I think, at a number like 100. This is a number 70 here. And this one is a number 40. So depending on, again, consistency of scoops. And this is going to be volume measurement. All right, another one here. These are what's called our dry measuring cups, right? Now these, again, if I wanted to do a cup of walnuts, a cup of flour, these are great that when, especially when you're doing your flours, your sugars, anything like that, you would take a big scoop, heaping scoop, give it a slight tap, and then scrape it off with a spatula or a palette knife, something to get a nice even cup. This is measuring, again, the volume inside of it. This is not measuring weight. The reason I say so is because what takes up a cup here, what takes up a cup here, isn't always going to weigh the same amount. It's going to measure differently. This is filling up volume, filling up a space. Switching gears, this is the only thing that will measure weight, right? There are many variations of the scale. This is a digital scale. There's the ounce scales, which are the spring form scales, where you would put a product on there, your bowl on there, move the dial to 0, and then measure your ingredients. For the digital scales, you turn it on. You would put whatever item you have that you're measuring in. So here's my bowl that I'm putting on there. And then I would go ahead and hit, there's a tare button right here, T-A-R-E. That is going to put my scale at 0. That way it's not accounting for what this cup weighs, right? Again, this is all weight. It's measuring the force of gravity pulling down on it. How much does it does it weigh? How much is that gravity? It's not measuring how much is inside. So that's where I want to make sure that you know the difference between the two. Because as I'm going through this, if we switch from a weight measurement to a volume measurement, flour does not weigh 8 ounces per cup like water does. Not everything weighs the equivalence that I'm about to talk about. So I want to make sure that we first know the difference between weight and volume. Right? That's going to be crucial. So the only other two other pieces of equipment here that I wanted to show you was a ladle. Right? Now, you have no idea how badly I want to show you what a spoodle is right now. A spoodle is one of my favorite pieces of equipment. The ladle, as you portion out, let's say soup, you're taking a portion out and then you'll have to pour it. It just seems a little awkward here in the arm motion. So instead, a spoodle is just a straight handle with the vessel at the bottom, the cup at the bottom there. And that way it's more of just a straight over. Not the point, I realize. But both of them are measuring the space it takes up inside. Is that volume or is that weight?
Volume.
Volume.
Volume, awesome, yes. I see a lot of you unmuting, a lot of you wanted to say volume, great. Okay, so those are the last two things that I definitely want to go over. And the PowerPoint slide that I provided on D2L does just show pictures of some of those. There's some other things like a peck and a bushel, different ways that food come in. And again, it's kind of a different language, and we'll learn that as we go along. Sometimes food is measured by the count, not the weight or the volume. So something like tomatoes comes in a 5x6 or a 6x6. That refers to how the tomatoes are laid in the case, and then that case is always a standard weight. So it comes by the count. Lemons will always come in a 40-pound case. I can get 85 count, I can get 95 count, I can get 140 count. Think of a box. If I shove 140 lemons in there versus 85 lemons in there, the 140 lemons are going to be a lot smaller. And that's going to be important for me when you guys are making apple pies and I order in the Granny Smith apples. If I get 150 count versus an 80 count, it's either you're getting really small apples, there's a lot of waste coming from them and a lot of work, or I get larger apples, you use less, there's less waste. So, there's different things that you want to look at. So count, volume, weight, again, how things are going to be packaged is going to be important. Okay, so I wanted to first describe, again, the volume versus the weight. Then I wanted to take you through, and I'm going to go ahead and share my screen at this point. I want to take you through the customary units of measuring. Just again, to refresh and make sure that we're all on the same point here. Now, I am seeing my screen full screen, so if you have any questions, again, please make sure that you unmute because I'm not able to see anyone at this point. All right, customary units of measure. So I talked about the different measuring equipment. So we have our nested or dry measuring cups as well as our measuring spoons. So I have those as well. Again, these are measuring volume. Then you have your measuring cups that I showed you. These come in all different sizes, cups, pints, quarts, gallons. You could get half-gallon ones. They do have the, the customary measurements on the one side. So this would be our ounces, our cups and pints. On the other side would be the metric measurements, and we'll cover that here in just a moment, okay? To measure weight, again, we have our scale, so the digital scale. This was that ounce spring scale that I was showing you. They come in ounces, pounds, as well as then we also have the large purchasing scales that could measure up to, I think it's 500 pounds. That would be huge industrial. And then here's a baker scale, which is a really cool item that really is underused. What it is a balance scale to where you have that big weight tray. That's where you would put your flour and your ingredients. So to counterpart that, you have this white little container on the side here, usually filled with salt. So what it does is that container accounts for the weight of the bowl that you're gonna put the flour in. Then these weights down here, these gray weights, there's 1 pound, 2 pound, 4, 8, and 10, I think. So those you would then put on the one side. As you fill the flour, it balances up, and then you have your measurement.
Chef Patty.
Yes.
Are you sharing your screen?
Am I not sharing my screen?
I'm not seeing it, or at least I'm not.
Yeah.
Thank you for telling me. I hit share. Oh, I forgot the extra button. There you go, guys. Thank you. Yes, please tell me anytime. That's probably why now I can see you and the screen. Okay. You can see that okay now, right?
Yeah.
Okay, good. Good, good, good. So this is the balance scale on the bottom right, now that you can see it. So this white tub is where I put the flour, and this white container over here is where that's the weight to counteract this bin. Then these gray weights would go on this side here, and as you fill the flour, it would come up and balance. If you needed to do any ounces, this goes through 16. So let's say that you needed 4 pounds and 4 ounces. You would put the 4-pound weight, you would move this over to the 4 ounces, and then start filling your flour, and it balances up, right? So like I said, it's a pretty cool piece of equipment that no one seems to ever use, unless you're measuring out a large amount of flour. That seems to be the most common time that you would use that. Okay, I did show you the, go to the next one, the scoops, as well as the ladles. This is my spoodle here. Again, one of my favorite pieces of equipment. It seems to just be a really good spoon. I don't, but it does have the measurement on the handle here. It'll say the 2 ounces, 4 ounces. They come with holes in them, perforated. If you need to strain out some liquid as you're portioning, or whole. The scoops here again, and then the ladles, which come in all sizes. I mean, there's a portion of an ounce all the way up to, I think the largest one I saw was a 64 ounce, so 2-quart scoop, which is pretty huge. All right, I want to make sure everyone is clear on some of these abbreviations as well. Let me make this a little bit larger for you. I will be using these abbreviations regularly. So a teaspoon is written out as a lowercase t or TSP. For my sake, I usually will just write a lowercase t. For tablespoon, it's an uppercase T or TBSP. Cup can just be written as a C. Pint, quart could just be PT or QT. A gallon is a capital G, which is important because a gram is a lowercase g. Fluid ounce makes a difference because if we're talking water or any water-like substance, 1 cup is going to equal 8 ounces. So writing fluid ounce is going to be important. I'll be honest, that's probably one of my downfalls there. I just assume everyone knows what ingredient I'm talking about. So I definitely, that's one of my goals, to be better writing the fluid ounce in there. For ounces, that is then a weight measurement. That should not be measuring liquid, and that's just the OZ. I cannot see what that is. I'm guessing that's the pounds. There we go. Okay. The pound can be written as LB or the pound number sign. Okay? And again, I'll do the number sign probably more often. Each is just the EA, bunch could just be BU, and TT refers to taste. Okay, so just so again, you're familiar with a couple of those. We talked about the count. Again, a lot of times that's going to be used when you're talking about a whole apple, a whole pear, a whole orange, a whole chicken. There's a lot of times counts referred to. So for volume, here are the measurements that I want to make sure that you're familiar with. For the teaspoons, tablespoons, in 1 tablespoon, there's going to be 3 teaspoons. So 1 teaspoon is 1/3 of a tablespoon, or I can put 3 of these teaspoons in 1 tablespoon. For some reason, they do not make a 1/2 tablespoon measuring spoon. When you buy the set here, you get a tablespoon, a teaspoon, a 1/2 teaspoon, and a 1/4 teaspoon. It does not give you a 1/2 tablespoon. Does anyone know what measurement we could use if we needed a 1/2 tablespoon?
1.5 teaspoons.
Absolutely, I heard a couple of you. 1.5 teaspoons. That's why it's important to know there's 3 teaspoons that make up a whole tablespoon. So if you only need 1/2 of one, then you only need 1.5 teaspoons. So that is something that, just one example, but so often you need to take a measurement that's given to you and change it into something else. And that's what I'm really going to hit on today. So the very first step is memorizing what these equivalents are. The idea that 1 tablespoon is 3 teaspoons. The idea that 16 of these tablespoons will always equal, find my cup, will always equal 1 cup. It does not matter if I am putting flour in here, although I shouldn't because it's a liquid measurement. It doesn't matter if I'm putting water, it doesn't matter if I put honey. 16 tablespoons will always equal 1 cup. It will always fill 1 cup. When I am talking about 2 pints, now 2 of these cups fit into 1 of these pints, right? 2 of these pints fit into a quart, and 4 quarts fit into a gallon. So everything kind of flows into each other, and that's what this symbol is over here with the G. A gallon is represented by 4 quarts. Each of those quarts is represented by 2 pints, and each of those cups is, or each of these pints is represented by 2 cups. Another way about thinking about this is the ounces that each represent. And I'll be honest, that's probably easier than memorizing how many cups are in a pint, how many cups are in a quart. Memorize how many ounces are in each item. A cup has 8 ounces, has 16, because again, a pint is 2 cups. A quart, which is 4 cups, 4 times 8 is my 32 ounces. A gallon is 128 ounces. Also, to note, there's 2 tablespoons in every ounce. An ounce measures 1 tablespoon. And this is for water. This is for any water-like substance, so your fluid ounce equivalence. The reason I say that is because a cup of flour, and we'll get to that. Okay. So what do you do with these? If this is the first time you're hearing of it, I really hope not, but you need to memorize these. It will make your life much more difficult going through any of this if you have to reference each time how many ounces are in a cup, how many ounces are in a gallon, how many tablespoons are in an ounce. Those are things you want to memorize and have them down pat. Your homework assignment was pretty much that. Tell me how many cups are in a pint. Tell me how many ounces are in a gallon. Now, please note that that homework assignment is due by midnight tonight. So that way I could answer questions today and still allow you a little time if you had it to complete that. All right, I mentioned bushels and packs. I don't want you to be too concerned with what those are equivalent to. However, sometimes I'll order zucchini and it's a half bushel. Eggplant, it's a half bushel. Getting crabs, getting things at farmers markets, a lot of times they're in packs and bushels. So just recognize that there is another form of container of measurement here that is mentioned. I talked about the portion scoops already, and again, that's going to keep a consistent portioning for you, measuring volumes, measuring the space that it takes up. So then we move on to weight. There's a few equivalences that you need to know. The 1 ton equals 2,000 pounds. I would not overly concern yourself taking up any memory space with that one, but the 1 pound equals 16 ounces, that's extremely important. Right? So again, 1 pound equals 16 ounces. Otherwise, we'll get into some metric measurements with weight, but that's really the big one to memorize there. Any questions on those measurements?
Wait, I do have a question.
Sure thing.
For the bushel and stuff, do we have to deal with that for baking?
No, generally you won't. It's extremely rare. Over 19 years, I think I've probably come across a bushel or a pack maybe a dozen or 2 times. It's extremely rare, yeah. And that's
Okay.
where I just want you to recognize if you hear a bushel or pack, that's the container, that's the measurement that things are purchased in. That's pretty much it. Be able to reference it. At this point, if I order something and it says it's a half bushel, I will have to Google and look and see what a bushel can, of that exact item weighs or how much is in there. It's going to be different based on what product you're getting. I would not take up any memory space with anything more than knowing it's that.
Okay, thanks.
Okay, I'm going to then, the last one, what I wanted to just again reiterate is if I take a cup of water, it is definitely going to fill up the cup space. If I take a cup of flour, even though I'm using the wrong measurement, it's still going to fill up the cup space. It still is the same volume. But if I now take it and put it on my scale and I measure my water, it's going to measure 8 ounces. If then I put my flour on there, it's only going to measure more around 5 ounces. Can you see the density? The water is heavier than flour would be. Powdered sugar, super light. You know, think of things that are very light but still take up the same amount of space are going to weigh a lot less, right? That's a concept that, again, hopefully you've been presented. For the most part, anything water-like. So like your oils, your vinegars, milk, eggs, your flavorings, anything that for the most part is liquid is going to weigh that 8 ounces per cup. Things like honey, though, that are denser, maple syrup, corn syrup, things that are thicker, you know, take longer to pour out, they just seem heavier. Honey is actually 12 ounces it weighs for every 1 cup. Then again, think of things that are more dry ingredients are generally going to weigh less. Things like your nuts, having them finely ground are going to weigh more in a cup than if you had whole walnuts in there, because there'd be all this empty space. Okay? In your textbook, which I do have, in your textbook at the back, there is an appendix here, Appendix C on page 576. Right? This is also found in the Book of Yields, but I find that it's important to actually show you here what's in your textbook. So what it is, I don't know that I can get close enough for you. I'm trying. Okay, you can see the product here. There's allspice ground. The volume, so it's saying per tablespoon weighs 1/4 of an ounce. Oh, I'm trying hard. Okay, so we know 1/2 ounce to weigh, or to be 1 tablespoon. This is saying for every tablespoon of allspice, it only weighs 1/4 of an ounce. So when you're talking spices, if someone were to say a cup, you could say that was 16 tablespoons, but that 16 tablespoons only weighs 4 ounces instead of a cup weighing 8 ounces. I'm really just presenting the concept here to you. I'll explain how we use this information. So that's always the ounce confusion. The idea that everything always weighs a cup and an ounce, and why are we learning all these equivalences or equivalencies? And then you're telling us that that only applies to half of the ingredients in the world, because half of those ingredients take up a good portion of it. So we want to make sure everyone knows, and we're able to use this information to manipulate different recipes, different ingredients. Because I always say in a kitchen, if the ingredient is more than 5, I lose count. Are you kidding me? I do my 2nd cup of flour, and by then somebody asks me something, I start talking, daydreaming, who knows? But I lose count after 2, let alone 5. So if I were to see a recipe that said 382 teaspoons, what? I don't know what other reaction to have other than you're kidding me, right? I'm not going to measure that. So the idea is I want to be able to go from 1 to convert it to something that I can actually measure. And that's where it's important to realize that not everything, if you had, and I had someone do this at the Chef's Apprentice and someone through their internship, I think the recipe called for 24 cups of flour. And she said, okay, great, 12 pounds of flour. And she made all these cakes with it. And needless to say, it did not turn out correct. It should have been more like 8 pounds of flour instead of 12. So again, you need to know that there is a difference. It's not everything that you can just do a real quick conversion on. Okay, so let me go through metric first, and then we'll go into more of how do we apply all of this here. You can still see my screen, correct? Okay. All right, so for the metric, now that's where I kind of fumbled on, what do I call the other ones? Customary measurements is what I talked about. It's pretty much the American version of measuring items. And I say that because metric system is used almost everywhere else. And why did America come up with our own? Because that's what we do. And I really don't have any other reason for you. So for us, it was easier for cups and ounces and all of that good stuff. But how it originated in Europe is the metric system. And the metric system uses liters, milliliters, it uses grams, it does not use ounces and pounds. And we'll get into that. So as a comparison, like I said, when you have a measuring cup, now I have a pint here, but it'll have all of the customary units on the one side, and on the other side, it lists milliliters, right? On the left here, you can see 1 liter equals 33.8 ounces. That is, I'm gonna say it again, 33.8 ounces, not 34, not 33, 33.8. 1 quart then is 32 ounces. So you can see they are not equivalent. A liter is 1.8 ounces more, right? So if you see a liter on something, you can't just automatically switch it over to a quart. It is slightly different. All right. And then aside from why is it around, where do we find it? Where do we use it? Can anyone give an example of where the metric system is used? Why would we need to know that? Does anything come in metric form?
Chef Patty, I might be able to like list an example possibly, but I don't know if it's right. But I guess
Okay.
I'll go. So I'm thinking one way that the metric measures can be used overall is more like in like science laboratories. So like scientists, like when they have to measure out like a substance or like a chemical that they're using, let's say for like medicine as like a vaccine, you have to know what metric measurement you need in order to make sure like that vaccine
Absolutely. I agree. My daughters get these little science kits all the time. And well, I did go through a lot of chemistry and science courses before, but everything is in milliliters and like 5 milliliters. You know, it's very small measurements. And that's exactly right. That's the whole purpose. Grams are the smallest measurement possible. 1 gram is the measurement of a blueberry. A blueberry weighs a gram. A paperclip weighs a gram. 1 milliliter is like a drop of liquid. So you're absolutely right. In science and in medicine, you certainly would need to. Yes. Cool. Anyone have another example for in food service? What type of food items, food or beverage items would come measured in metric measurement?
Alcohol.
A lot of alcohols I know come in liters.
Yes, I heard Autumn and Evan both there. Yes, definitely. Your alcohol is going to come milliliters, a 750 milliliter bottle. And you will need to know that that's 24 point something ounces. You know, because if you're trying to measure out in 3-ounce pours, but yet it comes in a 750 milliliter bottle, that's like 2 different languages. It's 750 milliliter bottles. It's 1.5 liter bottles. There's, I think, 350 milliliter bottles. There's 5-liter boxes of wine. There's all kinds of different sizes, but yes, all alcohol will come using the metric system measurements. Absolutely, good one. Otherwise, I'm going to say, because that's really the big one. Otherwise, it's generally going to be a lot of baking recipes. I will tell you the majority of baking recipes will use grams because it is an exact measurement. It is more exact than using ounces. Very often you need 2 grams, 5 grams, not 1/4 of an ounce. And on your scales, it only measures to 1 decimal point. So you're really kind of guessing. And in baking, you can't be guessing. It needs to be exact. So that would be the other one that it's really huge in. But just in general, I think a lot of recipes are coming out more and more with a mix of metric and the customary units. Everyone's kind of gotten rid of the whole, it's separated. Now they're very much intertwined. So with these metric abbreviations, how this started was the idea that you have a base unit. That base unit would be whatever your measurement is there. Turn it off. Okay, so if we're talking about our grams or our liters, that's our main unit. If we now want to decrease it and go to milliliters, it's 1,000 milliliters in every one of those liters. It's 1,000 milligrams in every gram. Then if we go in the opposite direction, we have 1,000 liters in every kiloliter. We have 1,000 grams in every kilogram. So it's just what, and that's really all that you need to know. There's no other ones really kind of in the middle, like you won't see the hectogram or the decigram. It's pretty much a swing of one way or the other. You have your base unit, your liter. Then you have 1,000 milliliters that make up that liter, or 1,000 liters that make up a kiloliter. You have your gram, 1,000 milligrams make up that gram, and 1,000 grams make up a kilogram. Hopefully that corresponds. This is one sometimes I might have to reference, okay? I just wanted to give you the concept there. These are the ones that I was saying, just kind of more written out here as far as how it swings back and forth. But what I want you to see on this screen is that the weight, the mass, the gravity pulling down on it, that's grams, milligrams, kilograms. The volume then, the liquid, the amount of space it's taking up is now your milliliters, liters, could even go into kiloliters if we needed to. Okay, these are the measurements you need to have memorized, and these are the three. So every ounce has 28.35 grams. Just like the liter, it's 28.35 grams, not rounded off, right? So a quarter of an ounce, you can see, is not going to be an exact amount, and that's why writing 5 grams cannot be put in an exact amount of ounces. You would round off somewhere. So that's where, again, that's going to be very specific. A kilogram is 2.21 pounds. Now remember, there's 1,000 grams in a kilogram. So 1,000 grams weighs 2.21 pounds. And then as far as a liter goes, you have 33.8 ounces. Again, we had already talked about that in fluid ounces because we're talking about liquids. So those are your measurements for metric. Those are what I'm hoping you have memorized already. And if not, that should be step number 1. Make some flashcards, get it memorized. Okay, I'm gonna go ahead and stop share at this point and make sure that I'm on speaker view. So I'm hopefully as large as I can be here. Now, I wanna start off with another concept here. And this is something that you might have learned in 2nd grade, 3rd grade, when you first started learning about multiplication. So is it true that actually, feel free to unmute yourself because you guys can just all pipe in here. So tell me, what is 5 times 1?
5.
5. 7 times 1?
7.
What about 1,000,000 times 1?
1,000,000.
Okay. So any number times 1 generally is going to stay itself, right?
Mm-hmm.
Can anyone think of a time if I were to multiply something times 1 that it would not be itself? I can't think. I think that's a pretty steadfast rule. So what I'm getting at is anytime I'm going to multiply something times 1, it's going to stay itself, right? So if I have a cup times 1, how much do I have?
1 cup?
Yep. A gallon times 1.
1 gallon?
Right. Okay. So I switched up some numbers now with some words and measurements in there. You all still need to be on the same page. Now, do you agree that 5 over 5 equals 1? 5 divided by 5
1.
equals 1. How about 20 divided by 20?
1.
1. 1,000,000 divided by 1,000,000?
Still 1.
Still 1. Okay, so there's many ways to write 1 is what I'm getting at. So what I need to do is the concept that I'm going to take anything times 1 is going to be that same product, right? So now what 1 equals doesn't have to just be in the form of a single number like that. I showed you that 5 over 5 equals 1. So what about the idea that 1 cup, what would I put underneath that to make that equivalent to 1?
1 cup?
I certainly could put 1 cup. What's another way to write 1 cup? What's an equivalent to 1 cup?
8 ounces.
8 ounces. Can you guys hear me okay?
Yep.
Yeah.
Okay, great. I'm trying to turn towards you every time I write at the same time. So 1 cup and 8 ounces, that's the same thing, right? So this equals 1. Is there anything else I could write besides 8 ounces under here?
16 tablespoons.
16 tablespoons. So 1 cup and 16 tablespoons. All right. Let me ask you something though, real quick. If I were to switch this Is 8 ounces over 1 cup still 1?
Yes.
Okay. So what I'm trying to walk you into here is that no matter what I do, where I put things, as long as the top and bottom are equal, it's going to equal 1, right? So I can then take this as it equals 1 and multiply it times anything, and it'll still come out times whatever, or equaling whatever that product was. So let me explain a little bit better. Okay, so let's say that I had 2 cups. And the question is how many ounces it is. Can someone tell me the answer like that? Because you know it.
16.
16 ounces. Terry, how did you figure that out?
I make soup every day.
You make soup every day. How did you figure out how many ounces are in 2 cups?
Because 2 if I wait, how many that is? I add. Okay, I did. Right.
That's okay. And that's kind of the point, is it's so second nature for some of us. We don't even think about it. Every cup has 8 ounces in it. So you did 2 times 8. Or you put in your head 2 cups equals a pint, and that's 16 ounces. It's second nature to you. That is awesome. And that's what I'm hoping it is. So what he did was every cup has 8 ounces. So he times 2 times 8 to show 16 ounces. That's great if it's something simple and you're able to do that. By all means, jump right to the finish line. Definitely. But what about those 384 teaspoons that I mentioned that I needed to measure in that one recipe? It's a little tougher. 384 teaspoons. I don't want to measure that. And I don't even, no, there's nothing I want with teaspoons. Nothing I want to do with the teaspoons. So what I'm going to do is go ahead and I need to change this. Now, how can I go ahead and change this? I can multiply it by 1, and I will never change the value of it. And that's the important part. I never want to change the value. I want to make sure that I have the same measurement. So 384 teaspoons went into a cup, and someone's like, here you go. Thank you. But how much is that if I have to do it again? So what I want to do is change this to a different unit, but I can't change the amount. So I'm going to multiply by 1. Go ahead, Ricardo.
I was about to say you can convert that to ounce instead.
Ounces would be, that's a great first step. Okay, so I know I can multiply something here that's the equivalent of 1, and I won't change it. Now I'm going to back up 1 minute before we go through this process. Okay, here is a fraction multiplication problem. 1/2 times 4/4, just because that's apparently what came out. So to do this, I would take 1 times 4 equals 4, and I would take 2 times 4 equals 8, right? 4/8. Now, the idea that I have a little extra over here and I can reduce this, kind of like the idea that I'm taking some of it out. But for now, I just wanted the concept of going across, that you understand that you would multiply across. Now, if I added units on here, okay, I added units. I have 1 ounce, it doesn't make sense, I realize, but 1 ounce over 2 cups times 4 cups over 4. So I'd have to keep those units going with me too. So 1 times 4 and the ounce times the cups. I have my units brought over. Again, it doesn't make sense. It's just the concept here. And then I have cups on the bottom, right? So now the idea is that you told me anything over itself equals 1. So I should be able to take the C over the C and get rid of those, right? Because those were over top of each other, and that equals 1, right? So let's apply that same concept here. I have a teaspoon measurement here. So I know when I multiply it out, I want to get rid of this teaspoon, and Ricardo told me ounces is what I want to go to. So if I put the t up here, I'm going to have a t squared, and then I'm in algebra, and this is not algebra, right? So I want to put the t down here. That way, when I multiply the t's out, I can cross them off, right? Okay. So that's my first step, figuring out what units do I want to use, because he said I want to go to ounces. So I want to take and put ounces at the top and the teaspoons down below. Again, this is down below because I want to cross it off. Even though I could write this equation any way I want, this thing that's going to equal 1, I want to make sure that it's beneficial for me and I'm not just doing extra work. So Ricardo, I need to make this 1. This has to equal 1. So the top and bottom have to equal each other. So how many teaspoons are in 1 ounce?
I'm not sure what's the answer for that one.
Okay, no problem. And you know what? Not everybody does. So do you know how many tablespoons are in a teaspoon, or how many teaspoons are in a tablespoon?
Of course, 3.
Okay, so let's do something that we know the equivalent, and that's what I wanted to show you guys. If you can jump right to 6 teaspoons per ounce, fantastic, but most can't. So let's not jump to ounces just yet. We'll take it to tablespoons. So you said how many teaspoons?
3.
So am I putting the 3 with the tablespoons or the teaspoons?
Teaspoons.
Right. Now, say it out loud. You're in your house. You may have someone looking at you, but say it out loud. 3 teaspoons equals 1 tablespoon. And then you know where you're putting your numbers. And I'm telling you, if you can just get that, you are solid, because everyone seems to, they'll put the 3 with the tablespoons or the 1 with the teaspoons. Like, you're writing something that is equivalent. The top and bottom need to equal the same. So now when I multiply it out, I have 384 teaspoons times 1 tablespoon. So that'll give me 384 tablespoons, because I know I'm going to have a T and T, so I'm just going to get rid of that. Divided by my 3. So now I'm still with tablespoons. So I could certainly do this, 384 divided by 3. But for now, I'm just going to leave it because I know I need to go a step further, right? You can keep going or start again here. Personally, I like to just continue on. Knowing that I did this, I would go ahead and write another time signal here, and then go ahead and do my tablespoons to ounces like we're going to do here. Okay, so let me get out of the glare for you. So now, Ricardo, can you tell me what our next, what is this going to be here? We want to get rid of tablespoons, right?
Yeah, so the tablespoons had to be at the bottom.
Awesome.
And the teaspoon, yeah, the teaspoons had to be up top.
Well, we got rid of the teaspoon.
Oh.
Now we're going from tablespoons to ounces, right? Is what you said? Awesome. So we'll put that up here. So now, what numbers do I put here?
1 up top.
So 1 ounce equals
16. Well, yes, 16 tablespoons. No. 32 tablespoons.
It's actually 2. I know I was throwing you off way.
Oh. No. It's like so many things.
And the pressure's on. So thank you for stepping up. No problem. No problem. So 1 ounce equals 2 tablespoons. So again, this equals 1. I am never changing the value. And that's what I cannot express enough to you guys. This has to equal 1 in order for you to continue on. So now these tablespoons, as I were to extend this out, 384 ounces plus I had the tablespoons out there. Oh, wait, you can still see that. And then 3 times 2 is our 6 tablespoons. And the tablespoon over the tablespoon, I can get rid of that. 384 divided by 6, and then that leaves me with ounces. So let's see what that comes out to be. 384 divided by 6 gives me 64 ounces. Now, let's say that we were talking, I don't know, apple cider vinegar. Is 64 ounces still okay? Is that the best measurement yet? Or can I do better? Colin?
Yeah, you could reduce that to a half gallon.
A half gallon, 2 quarts. Absolutely. I think there are more measurements that you could do, yet 64 is certainly recognizable too, right? I wouldn't be counting ounce by ounce, or, ounce by ounce necessarily with that, but think about your end game. If you were to measure this, could you measure that? Yes, you could, right? So we could have decided to take it right to gallons in the first place. So let's check that out. So, Colin, do you mind walking through it here with me? 384 teaspoons, if we want to take that to gallons.
So I would probably still start by going to ounces.
Okay.
So
On the top.
you'd have ounces up top. You want teaspoons down below. And that is 6 teaspoons per ounce.
Can we do the keep going?
Yeah, let me just do that calculation real quick. So it would be 384 divided by...
Well, I'm sorry. What I mean by that is, can we do the next multiplication?
Oh, yeah.
And then, so what Colin was doing was completing this and then doing the next step. Instead, what I'm doing is showing you keep going and doing your multiplication all at the end.
So then I would just go right to gallons. So up top you'd have gallons, and down below you'd have ounces, and down below you would have 128.
Equals 1 gallon. So now multiplying across, we have our 384. Notice how these teaspoons here and these teaspoons went away. These ounces and these ounces went away. And I'm only left with my gallon. Okay. So then down below, 6 times 128, I have no idea. But we know the answer is a half a gallon, right? So this is going to be, I think I did good on the guess. 768. Okay. So this is what's called the bridge method that everybody just shies away from. In the idea of like, I don't, no. It's just, what's this calculation? What's this? I want you to be open to it because you'll need it. There is very many times to where, well, I shouldn't say very many times. You're going to have to use it. It's going to get to the point where it's too complicated. If you can think of things in your head, if you could think of 384 divided by 6, divided by 128, great. But generally, not everybody can think of it that way. So I want you to understand this bridge method. And then let me take it a step further with the ounce confusion, how I mentioned that. The idea that not everything weighs 6 teaspoons in an ounce. Not everything weighs 128 ounces in a gallon. When I go to write this equivalent of 1, if I am talking about flour and it is 1 cup on the top, down below cannot be 8 ounces. It must be 5 ounces now. You're making that switch whenever you go and you put a volume measurement on one end and a weight measurement on the other end. You have to consult your book. You have to look and see what is actually equal to 1, right? And that's where I feel like a lot get hung up. When do I switch this up? When do I switch this up? I want you to always think of the concept that this has to equal itself. The top and the bottom have to be equal in order for you to put it in this equation, because I never want to change the value here of the actual measurement. Questions? Okay. Like I said, feel free to pipe in as you have questions. I just want to make sure that you're familiar with these concepts. What I want to take you to is, again, your homework assignment, as well as doing just a few ones on your next homework assignment. Because this was in general, what I wanted to show you, because again, as we progress forward, I need you to already understand this and be comfortable with this. So I'm going to go ahead, share my screen, and go to our homework assignment here. Take me a second, sorry. I suppose I could have done this before I pulled up the screen for you guys. All right, I'm just going to go in here to your assignment to make sure. All right, so your week 1 measurement equivalence. Again, what I was looking for is for you to be able to tell me how much is it, you know, what the missing measurement is. And these are equivalents. So in every tablespoon, there's 3 teaspoons. Every quart, there's 32 ounces. Every gallon, there's 128 ounces. Did anyone have questions on this? Any of you are unsure of yet? This is due by midnight tonight. I will look at them all tomorrow morning and make sure to get back to you with any corrections on here. But I'm hoping, again, this should be straight recall information. Maybe, oh, I got to memorize those metric measurements a little better, or I'm not quite sure on the this or that, it's throwing me off. But if you know these, then from there, then you would be able to kind of extrapolate that 6 teaspoons is every ounce. You know, you can pull some of those other measurements. Terry knows 2 cups is 16 ounces, like it's nothing. You know, everybody has your own memorization. So if there's certain areas you need to work on, please make sure that you do. Okay, what is due for next class? So if we go here to, and this again is in your D2L shell, just so you can see where it is. If you go to week 2, because it is going to be due on Tuesday, I have it in week 2 here for you. This is now measurement conversions. So it's taking it just past what you did with writing the equivalence. And now I want you to do what we did today. Okay, and that's not giving me, here we go. Okay, so I want to go through a few examples here for you. I am just going to let everyone know this is what I plan to do for the remainder of class, is to go through these examples. So hang out for one, just make sure you're on the same page. But if you're comfortable with it and you want to head out, by all means, use your extra 10, 15 minutes and go ahead and work on this and submit it. But this is where I wanted to end class with, is to go over some of these examples and make sure that you are okay working through this. It is a 2-pager as far as showing your work. So everybody has those questions. You do not have to show your work. If you can write, the first answer is, if you can just write 448 ounces, because you took 28 pounds times 16 ounces in every pound. If you did that, that's fine. You do not have to show me how you got to that answer. Where it would be beneficial if you could show me how you got to that answer would be if you got it wrong, in which case I could see, oh, here's where you went wrong. You thought it was 7 teaspoons per ounce instead of 6, or, you know, that's where I could help in guiding you if there was somewhere that you went wrong, as well as awarding partial credit. But you are not required to show me your work. Again, it's just if I can help out. If for some reason you were to hand this in and get every single one of them wrong, or let's say 80% of them wrong, I would start grading it. I would give you feedback on it, and I would hand it back to you because I would want you to redo it and resubmit it. Excuse me. You will get points for it. It's not as though you're going to get the 0 and not get anything. To continue to work on it. Again, I am here for you to succeed, and it does not do anything for you if you get a 0 on an assignment because you didn't understand it. So these first 2 assignments are really my checks to see where you're at in the math world, and what help that I could possibly be to you, and just to kind of guide you through that. So this assignment is going to be due by Tuesday night. That way, if there are questions, you can bring them to class with you on Tuesday, and I can certainly answer them live for everyone as well. Okay. So again, I'm going to go through a couple of examples, but beforehand, does anybody have any questions on any of the material I went over today? Okay, so I know some of you are overly familiar and comfortable with this. So again, feel free to pop off whenever you're comfortable, but I'm going to go through a couple of examples until 10:45 here for the last 15 minutes. All right. There is definitely a trickier one towards the bottom, but who wants to pick the first one I should go over?
Chef Patty.
Yeah.
Can we do number 5?
Sure thing. Okay. Yes, anytime there is a decimal or a small portion, it seems to throw things off a little bit. Okay. So we have 17.5 pints. And I need to get to cups, okay? So Who wants to walk through this one with me? Okay, not hearing any suggestions, so I'll just go ahead. I want to, again, multiply this quantity by 1. So I need to put something at the bottom and the top that equal 1. So I want to get rid of pints. I'm going to go ahead and put pints at the bottom. And then I do need to get to cups. Well, do I know how many cups are in a pint? I do. So
2.
absolutely. So since I already know that, that's going to be my equation. See, in the past, we didn't necessarily know that it was 6 teaspoons per ounce. That's why we went to the tablespoons. Then we went to the teaspoons. So if you know and you can get right to the finish line, go right to the finish line. So again, I got to say this out loud or else there's a very likely possibility I'm going to mess this up. So 2 cups equals 1 pint. Right? That way you put them in the right spot. I can't tell you enough. 90% of everyone's error is putting those numbers in the wrong spot. So say it out loud. Make sure that you're saying what is actually equivalent, equal to each other. So at this point, 17.5 times 2 gives me 35 cups. 17.5 times 2. Again, these pints go away with these pints. Right? And I'm asking you for cups. So there's no need to reduce it anymore, put it in any other terms. That's what I'm asking you for, is to transfer it 2 cups, right? Good one. All right, I'm gonna pick, how about this one down here? 1.5 gallons equals how many tablespoons, okay? So 1.5 gallons, I don't wanna write a half in a fraction. I'm going to change that to a decimal form. Okay. If it's a fraction on a fraction, and it just sounds like a mess. So 1.5 gallons equals how many tablespoons? I don't, off the top of my head, know how many tablespoons. I should be able to figure that out. But instead, I'm going to go to ounces because I know how many ounces are in a gallon. And then I can go from ounces to tablespoons. Kind of plot out your plan ahead of time. So I'm going to do gallons on the bottom. I have 128 ounces for every 1 gallon. And then I have ounces now. Gallons went away. Gallons went away. So if I have ounces, I'm going to put ounces down here. And I want to get to tablespoons. I know how many tablespoons there is in an ounce. 2 tablespoons for every 1 ounce. And again, all these measurements are water. You're not worrying about it. It's all water. Okay. So there's none of that whole weight measurement. No, water. Okay. So ounces went away. Ounces went away. 1.5 times 128 times big number. It's like a juggling act. 384 tablespoons. But that seemed really close to the number I used before. Did I do teaspoons instead of tablespoons? When we did the half gallon, that was odd. Okay. I don't know that any of you have looked at this to see if there's any other ones how about one of the, how about a liter one? 750 milliliters. That's that bottle of wine. Remember how I said that bottle of wine is 24 point something ounces? All for comedy relief here. Okay. 750 milliliter equals how many ounces? Anyone want to walk through this one with me?
I'll take a crack at it.
Thank you.
So first things first, I would turn milliliters to liters.
Okay.
So there's 1,000, I would have milliliters on the bottom and liters up top. And there's 1,000 milliliters per 1 liter.
Awesome.
And then I would go from liters to ounces. So I'd have liter down below. And up top, I would have ounces, and that's 33.8. Was ounce the final goal?
Yes.
Yeah.
Awesome. So that takes care of milliliters went away here, and then liters went away over here. That's where you need to know that 1,000 milliliters equals a liter. So it will come up. And again, there's equivalents there for you to memorize. So 33.8 divided by 1,000. Did you get 25.35? So I was wrong. It's not 24 ounces-ish. It's 25.35 ounces. So that's going to be important. Let's say a bottle of wine, and you're planning on a 3-ounce pour out of that bottle. Well, you can get 8 full pours out of it, and you'll have a partial left over. So, you know, what you could do is like a 3.2 ounces or something. But regardless, when we're doing like the gala dinner, we would think of a bottle of wine per table of 8, knowing that it must be that 3-ounce pour in order to stretch all the way across. Okay. I know there's one other tricky one. Or maybe I took all the trickiness off. Oh, how about the 1/2 cup to a milliliter? Anyone want to take that one on? Did you see what I started doing? I started writing half, like it was going to be 1/2 cup. Again, change it to the decimal. Okay, I want to change this to milliliter. I don't know any conversions of cups to milliliters. I got nothing there. But I do know ounces, and then ounces can go to the liters, and liters can go to the milliliters. Right? Let me just sketch out what I'm thinking here. If I do cups and ounces up here, I'm going to get rid of my cups. If I do ounces down here, and I do a liter, now I have liters. Liter down below, milliliter up top. This is that whole bridge method to where I'll be able to cross off my cups, cross off my ounces, cross off my liters, and I'll be left with the milliliters. So now what I have to do is actually put in the equations that equal 1, so I'm not changing it. So I have ounces and cups. There's 8 ounces for every 1 cup. Liters and ounces, 33.8 ounces for every 1 liter. And then 1,000 milliliters in 1 liter. Right? So without even doing the calculations, just to show you how you go through the process of it. And then again, you would multiply straight across. 0.5 times 8 times 1,000. We're looking at 4,000 divided by 33.8. Okay. I want you to see how to get to the finish line. There's many ways there, but for the most part, this is the most mechanical way you can think of it. And honestly, I don't like to memorize any formulas, any of that jazz. I want it to be common sense, clockwork for me. So hopefully this may be presented in a little bit different, because this seems to be everyone's hang up is on this bridge method. Why do you do this? Why are we even talking about a bridge in math? Come on. You know, it just seems to really hold everyone up here. And the main concept is every time I multiply, it's a value of 1. It does not matter what's on the top or bottom. It will always equal 1. When it matters is so that you can get rid of those units, because I'm going to keep changing that same amount that's in here, that same volume. I'm going to keep changing it. When we get to now, we're skipping from a scale from the measuring cup, then we'll talk a little bit more, right? But for now, this is just all water on this assignment, all liquid, so you can just do a straight conversion. Any questions on this? Would you like me to do any more?
Nope.
Okay. Sounds good. So Again, this is on your Dropbox assignment, just to show you two different ways to get to it. You could certainly, in your table of contents here, go to week 2, in which case you will see it in the assignments. But perhaps another easier way for all of you is at the top, if you go to Dropbox directly, I will have each one labeled with the week that it's due. So you see your week 1 equivalence. Of course, I'm looking at it from my perspective. Okay, from a student's viewpoint. Here you go. So here's where I would see the measurement equivalence. Here I would see the measurement conversions. And then there's the other assignment that will be due next Thursday on local food distributors. So you can just go right up to the top to Dropbox. Again, I am putting information in D2L for you as supplemental, not required for you to view. So if you just want to go right to where the assignments are, right to where the quizzes are, right when you know that things are gonna, are due and you would like to go directly there, you certainly could. Okay. Any other questions that anybody has for today?